All right, this is physics review video number 4. This is on projectiles. Projectiles, if you look, are objects launched under the influence of gravity only. We send something into the air, like say, I don't know, a baby, and into its mother's loving arms. And so when we launch it into the air, we can launch it in different angles and such, but what we're going to come up with is 2 different ways to represent that launch. One is I named a cliff projectile because it's from a given height and it's horizontally off of that cliff or that height, and then it goes in a parabolic path, which turns out to be half of the other type of projectile trajectory or path, which is Duke's. Duke's goes the full D, if you look at it, turn it this way. So that's the full arc, the full parabolic path. You need to know that, not hyperbolic, not straight line, but parabolic path. And the cliff projectile goes off like this. So say, for instance, we were to take, again, a baby, and launch this baby off of the cliff into its mother's loving arms. So there's mom right there with a nice dew, very nice. And here's the baby. Now, we're going to give this baby an initial horizontal velocity. I'll make that look a little bit better. Initial horizontal velocity, we're not going to be too rude to the baby. I don't know, 10 meters per second, about 20 miles per hour. Babies have soft bones. They should be able to deal with that kind of force and acceleration and velocity. So, now, this is going to be a 25-meter tall cliff, which if you actually did this, by the way, would get you in trouble with DSS, so please don't try this at home. Now, the path of the baby, as said before, is going to be parabolic. It's going to be half of a Duke's because this is a cliff projectile. And again, by definition, it's launched horizontally from a given height to some target, usually. And so the question is, if mom, let's put mom a certain distance away, okay? Let's put mom 30 meters away. That's pretty far. This is a little iffy for the baby. We'll see what happens. The steps for a cliff. First of all, you find the time using the dy equation. That's EQ for equation. And then you find the range, which is dx, range is dx, using the dx equation. Mr. Wilson, I've never heard of dy and dx equations because that's not on my reference tables, which of course I have at my side all the time. Now, and you should too. I'm saying as if I were a student, I have them at my side, along with my calculator and along with my degree deodorant. So, my question is, how do I figure that out? Well, what I mean by the dy equation, I'm going to put this down over here. The dy and the dx equation are the regular d equation from mechanics with, let me get rid of this so it's not confusing, with x values or y values plugged in. If I plug in the dy, well, the dy, the height or distance vertically is 25 meters. Tricky, the initial vertical velocity is 0. 1/2, 10, we're going to estimate many times. You can use 9.81 if you really want to. And 10 meters per second squared. And then time. We don't know how much time it's going to take to fall or project, but we do know it's going to be around 2 point something seconds because we know 1 second falls 5 meters, 220, 345. So if I plug this in, I'm going to divide by 5. So 5 equals t squared. So t works out to be the square root of 5, which, wait for it, I know that Poppy is calculating this. Let's see, second square root of 5. And of course, Moose there in the back, 2.23 seconds. Thank you, Moose. We're going to call it 2.24, pardon me, if I round to 2 decimal places, hundredths place. So 2.24 seconds, that's how you find out the time. It's based on the height. Makes sense. And then, in other words, if you go a higher height, it's going to be in the air longer. The dx equation is the same thing, the d equation again, except with x information. So now, your horizontal velocity is 10. 10 meters per second times 2.24 seconds. That's going to be 22.4 meters. How come I didn't do the second part? Well, because the acceleration in the horizontal direction is 0. Gravity is the only influence on this which is acting vertically. No sideways gravity as far as I know. So, 22.4 meters, 30 meters mom. Mom better get trucking or DSS is going to be after her because she's a little too long there. Thank you.